Okay? And before we talk about this, does anyone know what the word derive means?
So like get out of?
To get out of? What else? Talk amongst yourself. For 30 seconds here, make some guesses with someone near you. What do you think this word derive means?
Take out, maybe.
So talk to each other. I'll give you literally 25 seconds, then we'll talk as a group.
What do you think derive is?
To take out.
Yeah, it's like.
It's like take out.
Open the door, like.
Any thoughts?
Yeah.
No clue. It's fine if you have
Mentioning the really basic, I mean, I think it's something like minus or.
Yeah, that's
Okay.
You can just look away your hand.
So to wrap up and back together, can you remind me of your name? Calvin. What did you say derive means?
Get out of, get something
Yeah, so that's a big part of it. Our goal today is to derive and apply formulas for circles and for triangles. Derive means what you said, to get out of something. It also means to understand where something comes from. So like Ed throws all these formulas at me, right? He's like, distance equals radius times sine, this is this, this is this. He gives you all these formulas. But what I want to do today is take two really useful formulas to actually teach you why they work. So that's our goal. Does anyone have any questions about our goal? No? All right.
Wait, one question.
Yeah,
Did you have to ask, like, you go to clinic today?
I did. Yeah. I don't just get to walk in whenever I want to teach classes. Yeah, I asked it a while ago if it was okay if I came in and taught a lesson. He said, yeah.
You can make soda out of that bottle.
Yep. Okay. Soda stream.
He chases it.
Alright. So again, with someone around you, make 3 observations about this map. You can write that on the first slide of your paper if you would like.
You're my partner.
It's right here. Just 3 things that you notice. They don't have to be mathematical. Anything you notice about that map. Feel free to carve that up, work on your own, discuss in a group, whatever works best for you. 3 observations. We'll take another minute and 45 seconds.
Oh, yeah. What does this do?
I'm not gonna try.
What color?
Hats.
That's
Does he write like me? You write like me?
No, he writes it up.
Okay, so another 10 seconds or so. Fine if you don't
Oh, yeah, you can't see
want to
that.
have that.
You can see. What does that say?
I'm saying, you can't see my handwriting, you just wrote it down.
Alright, so back with me. If you're with me, let me see your eyes. Great. Thanks a lot. You guys are awesome. Okay, 3 observations. Give me 1. Karen.
Often.
Boston. Great. So this is the Boston area. What else? Go. It's a map. Very good. What else? Oh, same thing, map?
Yeah.
Cool.
There's roots on it.
There's roots on it? Okay. Do you recognize any of these roots?
Route 1,
Where's Route 1?
right under Boston.
Yep.
To the south of Boston. Yeah.
Cool. What else?
93, north and south.
Very good. So we get 92 in here.
But then,
Good. Next, same deal. Take 1 minute, make 3 observations about this next slide.
Circle slash.
Do you notice any similarities between that slide and the one before? Can you make any connections between the map and what might look like a bullseye?
Boston.
How so?
Just go measure it on my axis.
Okay. Should write that down. That's a kid. So another 10 seconds to wrap up your thoughts. Alright, if you're with me, give me your eyes. Thank you. 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 Cool. Chad, what do you got?
It's longitude and latitude.
Longitude and latitude. What do those words mean?
According to.
Okay, cool. Okay, so the coordinate plane, right? Okay, good. What else?
There's positive and negative numbers.
Great. Positive and negative. What else?
It has numbers.
It has numbers on it. Okay, very nice. What else? Any other thoughts about this? Here's an important question. Do you all see any similarity between this right here and the one I showed you before?
Yeah. They were kind of the same.
Oh, I know.
No.
Okay.
I know.
So I'll take hands.
Take mine. Wait a minute.
What do you think?
Okay. Alright, check this out. The ocean cuts off this for a second. And this sucker right here is like cut off too.
Okay.
It's like a half.
So like this side on both of them is cut off. Okay, great.
They're all kind of shaped like circle or diamonds.
I'm gonna take this hand. Yep.
Yeah, if you go back to the other one, you could actually see, the first big line, the outer line, the outer part of the circle, the same thing here. Then you can see another one that's identical to the smaller circle, to the map there. You just have to
Did it? So what's your name again, man?
Richie.
Richie. Did everyone hear what Richie just said?
That's the map.
Y'all heard that?
I'm American.
Okay, he cracked my code here. Yeah, that's what I was trying to kind of illuminate for you guys and girls. That this big ring, the outside ring that goes around Boston, right, is circular. And it's not like Route 1 or 93 that are straight roads. It does a big circle around Boston. And so does this one here. This is 95. They do circles around Boston. Does anyone know why they build roads that make circles around cities?
So you can go around them?
Yeah, why would you want to go around a city?
I don't want to go around the city.
Because maybe don't want to meet the streets and everything.
What happens in the city? That's a pain, traffic, right? So like Boston, Baltimore, Washington, D.C. have these big highways that go around the city. So that you don't have to go through the middle of the city. So these two roads, this one here and this one here, are 95 and 495. 95, as it goes around Boston, is 10 miles away from Boston the whole way. Okay? 495, this bigger
Is that
circle.
on purpose?
Yeah, I was going to ask that. They did it on purpose, right?
Yeah. Yeah, they did. 495, this bigger one, is about 30 miles away from Boston all the way around. Do you notice the numbers I put on your coordinate plane?
Yeah.
10 and 30, right? Okay, so remember that for later in the lesson. 10 and 30, remember that for later. Okay. So, if you turn to the next page, I have some very important vocabulary I would like you to copy down right here. These are going to be the words that we talk a lot about today, so I want us to all have the same definition for them. You can just literally copy word for word what I have right up here on the block where it says circle vocab.
Yeah.
If you can't see, feel free to come up.
Point. No, just wait. Midpoint, on turn to midpoint. On turn to midpoint. No, I have chicken scratch.
Yeah, feel free. Come on up.
Cheto, se ve que y se ve Cheto.
Yeah. I don't know how to
You told me to get straight, George?
No, my little dude has one. My friend has one. We play Batman Legos all the time.
So we've got the midpoint. The definition of a midpoint is the point in the middle of a circle, equidistant from all the points on the circle. Equidistant means the same distance. We've got diameter, distance through the midpoint across the circle. We've got radius, distance from the midpoint to the edge of the circle, which is also half the diameter. It's a useful thing to know. And then circumference, which is the distance around the circle. So again, give me your eyes when you're all set with copying those down.
You don't think it's weird when you look at yourself?
It is weird.
You don't be like, did I really do that?
Yeah. Well, that's why I'm doing it, right? To kind of see those things that I don't think about. And if they're not good, change.
You want to see yourself.
Also, feel free to fill in the drawing piece if you're waiting on people. Draw what you think those vocabulary terms might look like. Looks like most of us are basically there. I'll leave this up for another 15 seconds. Alright, so give me your eyes if you're all set with this. Thank you, thank you, thank you. All set, thanks. Chad, you all set? Calvin, you all set?
Yeah.
Great. Alright, folks, so any questions about these terms up on the board? We're going to talk about them a lot today. Midpoint, right? The middle of the circle.
What's the difference between a radius and the midpoint?
You wrote on that?
We'll fix that later.
You know this.
Don't tell that, right? That was there before. So,
Oh, yeah, like nothing.
pretty easy. So yeah, midpoint, point in the middle of the circle. Diameter, have you all heard that word, diameter?
Well, I had a question.
Okay.
What's the difference between the radius and the midpoint?
Can anyone answer that?
No, the radius is halfway. The distance halfway to the middle of the circle. You get it? That's the midpoint. That's the radius from here to the middle.
Oh, that's
You know what I mean?
this.
Is that the distance from the
Yes.
Did that make sense?
Yeah.
Yes.
Maybe you should
Oh,
say-
Yeah, so the diameter goes across the circle, right? What's the radius?
This from the midpoint to the edge of the circle.
Without even looking down, great. And the circumference.
The distance around the circle.
Distance around. When we're usually working with shapes, what's the word we use for distance around? Perimeter. Right? Perimeter. In the case of a circle, the perimeter, we call it circumference. Great. Alright, Alright folks, next question for you to talk to one another about. What is a ratio? Have you heard that word before?
People always speak like 40 to 20.
No, I don't think that one. So talk to each other real quick, 30 seconds. What's a ratio?
Something
Yeah, so in college there was something called KD ratio.
Yeah, so thanks, that's
Ooh, perfect. Perfect. Okay. Great. Remember that.
Yeah.
Okay.
Bean to cheese ratio?
You said cheese, what?
Bean to cheese ratio.
Beans and cheese, good.
Alright.
Rice and beans, man.
Alright. So I said that with me. Okay. So I heard at least two great applications of ratio. Richie, what did you say?
Like a KD ratio, like
Kills it.
yeah, kill death ratio.
Okay, what is that?
How many times you kill, how many times you die, when the game is talking about.
Well, percentage, you know, like percentage of
Has to
something.
do- has-
anything, right?
Has to do with percentage, yeah, absolutely. Okay, yeah, all these things are right. Okay, kill to death ratio, right? That's how many times you kill as opposed to how many times you die, right? It's comparing those two things. If you kill a lot and die a little, that's good.
Yeah.
That's what you want. You
And
want
and you have a win-loss ratio too. You know, if you got a lot of
Okay.
wins.
perfect, perfect. So a ratio is comparing two numbers, right? Any two numbers, when you compare them, that's what a ratio is. And ratio is really, really important for circles. So, Chad, you had one.
Oh, beans and cheese ratio.
Okay, so what's that?
Someone's nasty.
I learned that that's already.
That's already.
It's like, it's still good. There's more beans than there's cheese or something.
Okay, so it's
It's like 4 beans. And 3 slices of cheese. It's small slices of cheese, like strips.
okay, so it's comparing the amount of cheese to the amount of beans, right? Again, comparing two quantities. Great. Thank you. Alright, so now you don't need to sit down anymore. Here's what I want you to do. There's lots of circles in this room. I see at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I see at least 10. With a partner or on your own. I want you to get up, go around this room, pick 3 circular things, and measure the circumference.
What?
With these things right here. Hold up. Measure the circumference and the diameter and write them down. I have that in your packet on the next page.
What is pi?
So right here, you're gonna record circumference and diameter. I've got some string here, if that's useful. I've got rulers here, if you think that's useful. We'll take about 6 minutes.
Any
circle, any 3 circles.
one circle.
Oh yeah, I thought that was you. Because of that hairstyle you said.
How do we measure it though?
Oh, you're so funny.
How do we?
I want you to try to figure that
The door.
out. Oh, as far as the units, whatever. Centimeters, inches, doesn't matter.
Oh my God, yes sir.
I wasn't
Oh,
me, I
yeah, that
wasn't
was.
me. It wasn't. That was all him.
Yo, it's gonna.
You're so stupid. Why do you want to?
Yeah.
What the?
What are we doing?
Oh, you said it?
He's really gonna flip. Why do you want to say that?
Hey, you guys need to know. Just like this.
Listen. Alright, come on. What else? What? Huh? The clock. It's all the way up there. I'm talking about. Whatever. What? Oh my goodness. Leave it up to them.
Yeah. I'm letting know. This is what we're gonna do for radius.
Yeah,
32.
so to find the circumference, this should be useful.
You got 10. What is it made out of?
It's just, I don't even know.
Looks like you can rip it.
How about this? You wanna do this?
What else? Do you want to do something crazy?
Whatever,
Let's do another thing that's crazy. This right here.
There you go. Yes, head.
Yeah, do it.
Circle.
See how this is.
There you go. It is
You know, it's bad to measure people when they're not getting it.
15.
15
I
seconds.
think on my head is 15. I don't know.
Now what do we do? We calculate the hamburger times.
I put it down like a fair.
Head, which head yours?
To find the circumference.
Richie!
Leave it up to
Well,
them.
I want
He
you to
spilled some
take
shit.
the
See it?
and see how far it is.
It smells.
They kind of see it, but they make it run on.
Right?
Alright, so we don't take the cleanup crew and all that, don't worry about that. Don't take care of that, Chad. You got your measurements? Okay, so you need one. What about you guys? See if you can find it around.
He doesn't want us to find this. So how will you find out the circumference? I just want to
You cut it in half.
So you can use this string.
Oh, I see.
You look at the clock, 'cause I can't use it.
I would only Richie, he's so stupid. Why?
Hey, hey. It's alright, I'll take the blame for it, but we all know who really did it. We'll buy some, or I'll buy some.
Inga, Richard Inga.
This is brand.
Yeah.
Smallest sticky one.
6 and
That's what it looks like.
without mixing hands. Oh, we're gonna actually do Kenji's head. This is gonna be awesome.
Oh, damn, I didn't do it right. Like,
Do Kenji's head. Alright, my friend. And come.
we're gonna use it or this.
No, but do it right.
You guys
I don't know.
Yeah, it is. Hold on.
I love it.
I'm gonna take a picture.
Measuring each other's heads over here, perfect. That's what they're doing.
It's not even circle. So you need a little 22.
That's fine, guys. We'll take care of that. Alright, folks, so maybe another minute, if you need it. Please return your strings and things.
On the clock now.
I think we'll do the clock. I think don't step on the edge. Yeah, there you go.
I don't think that's gonna be happening.
No.
Yeah.
I'm gonna do that for you.
Let's
Yeah,
skip
come
that.
in.
for now. Let's skip that. for now. So, folks, I need you to take a seat again, please.
Man.
We're gonna get moving here.
No, I drank mine for no reason. It's still. I drank mine for no reason. It's still. I think I drink a little bit.
Okay.
I don't regret it.
Yeah.
How much of a look?
I don't know.
Richie, you coming in?
Well, this is natural. This is natural like it gets.
It's not good.
It's good. It's natural.
Alright.
What? I didn't know stuff. Pretty smart.
So, alright folks.
No.
So, I have another question for you. First of all, before I ask my question, someone tell me one thing they measured.
Kenzie's head.
Kenzie's head. What was the circumference of Kenzie's head?
That dude's head is 55 centimeters.
Okay. What was the diameter?
15 centimeters.
Okay. What else? What else did you measure? Okay. And what was the circumference and diameter?
23 and 7.
Okay. What
Well,
else?
I don't understand. Wouldn't the circumference have to be half of the? No, that. Okay, never mind. Forget it.
You're all set? Okay. What else? What else did we measure? I saw some people with the pin. Did anyone measure the pin?
I did
What was the circumference and diameter?
7 inches. Circumference, diameter was 2.5 inches, 2.5 inches.
Okay, great. So folks, here's my question for you. What do you notice if you look at your paper, or your partner's paper, if you look at your circumferences and your diameters, what do you notice about the ratio between all of them? Do they? So Santiago just said they change. Do they change? Are they all fairly close to each other?
I think it's measurable.
So let's take 1 minute. Talk to each other. What do you notice about the ratio between the circumference and the diameter? How many times bigger is the circumference? Karen mentioned it was half. Is it half? Is it more than half? Is it less than half? Take a minute and talk to each other. What's the ratio between the circumference and the diameter? Go.
What's the answer? 20. That was Richie.
So what do you think?
A coffee thing upside down. The first thing he did is flip it upside down. Like, Jesus.
Oh yeah, it is 3 times.
Yep, 3 times.
Yeah, very thick, so it's
Okay, so eyes with me if you're done. Okay, cool. Thank you. So I heard 3. I heard Santiago say they change. If a circle was perfect, do you think they would? Like obviously his head isn't a perfect circle, right? It has like bumps and hair and whatever.
No, it's pretty accurate. Look at 7 times 3 is 21. It's 23.
But that's not his head.
No, this one's is it.
Oh, which one? Which one?
That's 15 times 3, 45.
Yes.
Oh, yeah, your head's off.
So here's what I just did. I got you guys to think about the relationship between the circumference and the diameter. I asked you, what's the ratio between the circumference and the diameter? With perfect circles, it does not change. It's always the same. And it's
Times 3?
It's close to 3. It's the most talked about number in math.
3.14.
What is it?
Pie. Chicken pie.
So that's what we're talking about. We're talking about pi. Some notes on pi. I'd like you to write these down on the next page. Pi is a Greek letter, and it's used as a symbol for that ratio. So write these down on your next page.
Are they the ones that came up with that? Found that
Greeks are the ones who kind of discovered pi.
Math, right?
A lot of math, yeah, was discovered by the ancient Greeks. So this pi that everyone talks about, that 3.14, that is the ratio of the circumference of every circle to the diameter of every circle. If the diameter of a circle is x, the circumference of the circle is always 3.14 times x, pi times x, pi times the diameter. And again, we talked about derive. What you just did when you measured those circles, circumferences and diameters, you derived pi. You found out what that common ratio is. Does Ed keep like whiteboards in here?
No,
Whiteboards?
No.
Hi.
Oh,
you remember Meg had them?
Yeah. Now you can draw circles on it.
So you all have probably seen this. What you might want to add into your notes, this is what that letter looks like. That's pi. That's that Greek letter that people use to symbolize 3.14. This right here. So give me your eyes if you're all set with those notes. Okay? Maybe 20 more seconds here. It's fine if you don't get every single word. Here. Okay. If you didn't get every word, that's okay. We can go back. Here's my next big question for you, right? I don't want you to talk to each other about this. I just want you to think. Take 20 seconds in your head. Think about this question. If we know pi, and we know the radius or the diameter, we're just going to think for a minute. How can we find the circumference? So some of you said before, we're going to use the formula, okay? Given what we know now, what is that formula? Just think. 15 seconds and then we'll talk. Calvin, you had an answer for me?
Yeah.
So what are you thinking?
The radius times 2 times 5.
Radius times 2 times 5. Why?
Radius squared. Why?
Yeah, why? That's $1 million
Oh,
question.
I
Right?
don't know if I'm right.
I don't have to.
You got an idea?
Because the radius is half.
On two sides of it.
Well, I mean, if you don't have the diameter and you look at the radius,
Yeah.
it's only like 2, you got the diameter.
Okay. So if you have the diameter, what else do you need to get the circumference?
5.
Yeah. And what should you do with those to figure out how big the circumference is? Yeah, multiple. You guys just derived the formula for the circumference of a circle. This is what the Greeks figured out. They figured out that pi times 2 times the radius, or, like Kelvin said, pi times the diameter. That always tells you how long the circumference of a circle is, as long as the circle is a perfect circle. We won't talk about how to derive the area of a circle, but as someone here also mentioned, pi times the radius squared is the area of the circle. So if I have a circle, I want to figure out how long it is outside the circle, I'm going to use this formula right here, pi, or 3.14, times the diameter. If I want to figure out how much space is inside this circle, I'm going to use the bottom one, pi times the radius squared. Any questions on that? Great. Okay, so another city that uses circles for its highways, Paris, France. I have this approximate circle, right? How would I figure out how long this big boulevard is? What would I need to know? I only need to know one thing. What is it? The what? Yeah, that's exactly what I'm asking for, the circumference. My question is, if I want to know how long that road is, yeah, the radius. If I know the radius, I can figure it out, right? That's the radius, 6 kilometers. On your own or with someone around you, tell me, how long is it around this road? This radius is 6. How long is it around the outside? You should be, yeah, next one. Did everyone get those formulas? Should I put those back up?
Sure.
So, well, I can just tell you. If you didn't get it, the formula for the circumference is pi times diameter.
I don't know, I got like a number for the decimal.
That's fine. And then for area is pi times the radius.
Is this correct?
Why don't you talk to me? If you got the same answer, probably yes.
What you got?
You see the
So, yeah.
Awesome for you right now.
Yeah.
But what you guys,
And folks, feel free to calculate however. Oh no, if you did 2, this should be diagonal. If the 2 is in there, then you're all set. That's awesome. Oh no, this should be radius squared.
Oh, yeah.
So those are being, yeah.
That's
And
the
again,
most important decimal.
Look at who told me. I probably do it.
Why are you talking about? It is correct.
Oh, you want to sign?
What do you think?
Yeah, agree.
Great. What are you doing back here?
In there?
Okay.
No.
We'll talk soon. How you doing?
oh, I think you got it right.
I think I did this one.
Okay.
I timed the radius times 5 and
Okay.
37,
Would you use the correct?
2007.
So I think you're right on the money.
And I'm rusty.
Yeah, you just forgot the times too.
Is it really bad? You know how they make it
Richie's daughter's bathroom.
Alright folks, if you're with me, give me your eyes. Thank you. Thank you. Thank you. Thank you. Y'all with me? Great. So folks, what's the formula for circumference that we just derived?
pi times r times 2.
Pi times r times 2. In the case of this circle, What is the radius? What is R?
3.4. No, wait, the radius? 6.
Radius is 6, right? You with me? Doing
The
this.
diameter must be 12.
What root is true? Diameter is 12. If I take pi, pi is what?
3.14.
Okay. Multiply it by 6. Multiply that by 2. I should get the circumference. What I saw in most people's papers was something around, what, 37?
37.68.
37.68 what?
Kilometers.
Good, kilometers.
Oh, I thought it was.
Any questions about that?
What boulevard is that so I can like show off?
It's called Boulevard Paris.
Like, no, the circumference of this boulevard.
37.
Alright, so we talked about 95 and 495 going around Boston. Tell me the circumference of 95 if it made a full circle around Boston. Tell me the circumference of 495 if it made a full circle around Boston.
Okay.
So we're going to take about 6 or 7 minutes to do this, and then we're going to take a break. If you have any questions, let me know. I'm happy to help.
So we just have to find the circumference at the end. Remember at the beginning.
Yeah, I got what?
So remember, I said remember that those two numbers we talked about at the beginning.
10, 30.
So
For this one,
This is
just want to know the amount of time. Like whatever.
so this was 6, right? And that's 6 is R. So you're times pi times 2. And pi is 3.1.
Can I use my calculator on my phone?
Yeah, absolutely.
396.
95 is just
Okay, so.
remember, what was the radius?
Oh shit, they can move.
I think you know.
I didn't either. What is it?
Feel free to work together.
What's the radius?
The first thing you need is the radius of 95 and 495. Also, feel free to use calculators.
So it would be like 396, 360.
10 and 30.
The circumference of the circle is 90 by 95. The area inside the circle is 199.
So I'm going to give it to you if you don't already have it. Circumference of 95 is, radius of 95 is 10.
Yeah.
Radius of 495, 30. So you should be able to work with those numbers to find the circumference. And if you're feeling awesome about that, try to find the area. Use the area.
The circumference is 10?
No, your radius. For this one?
This one, right?
Yeah, perfect. That's right on. So now we're doing these. And the circumference of 95 is 10. The circumference of 495.
No, I'm not
Circumference of 95 is 10. So you use 10 for that.
495.
And then for the other one, it's 30.
How do we find out the radius?
I'm asking you if
I
that
told you at the beginning,
was
circumference of 95 is 10. I mean, radius of 95 is 10. Radius of 495
And my phone shut off every time, dude. So everyone in my wants to send me. It's so annoying.
George.
Hi.
Con el peso.
Huh? No, screw you.
No, you get the remote.
Because I was forced and I was selling it for like 200.
Well, I saw your mine for $50.
So,
500
Yeah,
get
I
it.
think-
1, 4,
Yeah, we still do that on
I dropped it.
Huh?
and again,
You
should
got
be
50 on it.
And by that one, he's
How you
mine,
doing,
bro. He ain't got stuff, right?
Yeah, I do.
How you doing?
I got the
Money, man.
195.
Even my mom uses that shit. Después dinero, shut up.
So, hold on. Look at it happening right now.
Alright, folks. So, just like Ed, I like to use this clock. You can leave your work right where it is, and I'm going to take a peek at it. We're going to